Alright, this is the third video on assignment 44, and we're going to be looking at applications and maybe a little bit of review of some one-to-one property logarithm problems at the very end. So problem number 9 here says, suppose that $50,000 is invested at 6% annual interest compounded continuously. So compounded continuously is going to tell us that we're going to use the pertinent equation, A is equal to PE to the RT. And then they're asking us how long will it take for the investment to grow to $75,000. So let's put all our parts out. So A, that's going to be your future value, or the amount that you have at the end of an investment or a loan, and that's going to be in money. P is your present value, and sometimes it's also called a principal. That's going to be also money. T, that's going to be time in years, and R is your interest rate, and then you got to convert your interest rate into a decimal. So for example, 6%, what that means is 6 per 100, or 0.06, 6 hundredths. Okay, in our specific example, A, P, R, and T, we're going to identify what we know. So $50,000 is invested. So that's what's happening right now. That's our present value. And then they tell us the interest rate is 6% annual interest. And then compounded continuously tells us that we're going to use the PERT equation above. So convert that into a decimal, 0.06. Okay, how long will it take for the investment? So they're asking us the time, so we don't know what the time is. And then to grow to $75,000. So that's our future value. So we're going to go ahead and plug that in. So 75,000 is equal to 50,000 e raised to the 0.06 times t. So this is an exponential equation, so we're going to first isolate the exponential, and the exponential is e raised to the 0.06t. We're going to isolate that first, and it's 50,000 times that, so we're going to divide both sides by 50,000. So 75,000 divided by 50,000 is going to be 1.5, and that's going to be equal to e to the 0.06t. We're going to try to solve for an exponent, and so to solve for an exponent, we're going to use the natural log. So we're going to take the natural log of both sides, and then recall the cancellation property or inverse property of natural log in e. So the natural log of e to the x is simply x. So we'll have the natural log of 1.5, and the e and the ln will undo each other, so we'll just be left with 0.06t. We're trying to solve for t, so divide both sides by 0.06. So t is going to be equal to the ln of 1.5 divided by 0.06, okay? And then we want a decimal approximation of this. So if you have a TI 30x2s, you'll hit the ln, it'll give you a parentheses, put in 1.5, close parentheses, and then divide by 0.06. If you have like a phone calculator, you type in 1.5, then hit the ln button. I think you might have to hit equals, you might not have to hit equals, and then, we're missing something here, let me fix it. And then we would have to hit divide, and then 0.06, okay? And that's how you do it in the cell phone calculator. If you don't see the ln button on your cell phone calculator, if you change it from vertical to horizontal and your screen's not locked, then oftentimes you'll get more buttons, okay? All right. So the ln of 1.5 over 0.06 is going to be approximately 6.8, and our units is going to be years because we're solving for years here. Okay, so let's go look at another one. So this time it says, how long would it take to double an investment at 9% annual interest compounded continuously. So you do see the magic word, or magic words, compounded continuously. It means you're going to use the PERT equation, A equals PE to the RT. And then we're going to identify our parts that are provided for us in the formula. So I don't see any money, but I do see an interest rate of 9%. So 9%, if I can draw a 9, let's try again. 9%, that means 9 per 100, or 9 hundredths. They're asking us the question, how long? So that's what we're going to solve for. Now, they don't tell us how much we're investing, what the principal is, what the present value is. But they do say it's doubled. Doubled in mathematics usually means times 2. So if our present value is p, then double that would be 2p. So 2p is equal to p, e to the 0.09t. Okay? This is an exponential equation. We're going to isolate the exponential. The exponential is the e to the 0.09t. So we're going to divide both sides by p. So we have 2 is equal to e to the 0.09t. Take the natural log of both sides to solve for the exponent. So you have the natural log of 2 is equal to, now e and ln are inverses of each other, so they're going to undo each other, and so we're left with 0.09t. And then divide both sides by 0.09. So t is equal to the natural log of 2 over 0.09. You're going to input it in your calculator just like you did with the previous example. So the natural log of 2 over 0.09 is going to be approximately 7.7 years. Now, it didn't matter what the principal was, so if you put a quarter in, how long it would take to double would be 7.7 years. Put in $1 million to double that to $2 million, it would be 7.7 years. All right. So next example, what interest rate compounded continuously is needed to grow $7 to $50 in 2 years? Okay, so they said compounded continuously, so that's going to be the PERT equation. A is equal to P e to the RT. A, P, R, and T. Okay. They ask us for the interest rate, so that's what we're trying to solve for. They say right now we presently we're growing $7. That's a present value, and we want to grow it to 50,000. We want to grow it to $50, and we want to do that in 2 years. So 50 is equal to 7e to the 2r. And this is an exponential equation. We're trying to solve for the exponent of the r here. So the first thing we need to do is isolate the exponential, which is e to the 2r. So divide both sides by 7. So you have 50 over 7 is equal to e to the 2r. We're going to take the natural log of both sides to solve for the exponent. So you have the ln of 50 over 7 is equal to 2r. Divide by 2 on both sides, and so r is equal to the natural log of 50 over 7 divided by 2, which is approximately 0.9831. And to convert that into a percentage, move the decimal place to the right twice, and so this would be 98.31% would be the interest rate required to increase $7 to $50 in 2 years. All right, last thing, just a little review of the one-to-one property for logarithms. So log base b of x is equal to log base b of y if and only if x is equal to y. Okay, so we're going to go ahead and solve. Log base 3 of x squared plus 5x is equal to log base 3 of 6. So we have equal bases, equal arguments here. So x squared plus 5x is equal to 6. It's quadratic. We'll set one side of the equation equal to 0, and then we'll cross our fingers that this factors. So a product of negative 6 that adds up to 5 would be x plus 6 and x minus 1. Set each factor equal to 0. Okay, so x is equal to -6 or x is equal to 1. Okay, and then we need to check when we plug this into the argument of the logarithm, we don't get any negatives or 0 because logs don't like negatives or 0. That's outside of its domain. So we're going to plug -6. Oh, sorry, I guess I'm going to do 1 first. We're going to plug 1 into where the x's are. So 1 squared plus 5 times 1. That's equal to 6, and that's what the other side is equal to. So that's good. And now we'll plug in -6. So -6 squared plus 5 times -6. It's going to be 36 minus 30, and that's also 6. And so both solutions are good here. Okay. All right, let's do one more example here. So we're going to solve the natural log of -36 minus x squared is equal to the natural log of 13x. So -36 minus x squared is equal to 13x. This is quadratic. We want to set it equal to 0. Cross our fingers that it factors. It's easier to factor if the x squared is positive, so what we're going to do is we're going to move everything over to the right-hand side, so add 36 and x squared to both sides. So we have 0 is equal to x squared plus 13x plus 36. Okay, and then product of 36, that adds up to 13. That is going to be x plus 9 and x plus 4. Set each factor equal to 0. And so we get x is equal to -9 or x is equal to -4. And certainly we can go ahead and evaluate these in, but I'm going to go ahead and look at the argument of 13x. That's inside the logarithm. Logarithms are happy creatures. They only like to be fed positive numbers. 13x must be positive. So divide both sides by 13. So whatever your answer is, it must be greater than 0. However, both are solutions. -9 and -4 are negative, so those don't work. And so this is a no solution. The two answers you found do not work. Okay. I might post a video on some more examples of solving exponential equations with unequal bases. So take a look in the Blackboard for that. Alrighty, we'll see you next time.